Question number 10, we have a figure. It has a semicircle and we have a rectangle. It is given that QRS has a rectangle R, has a radius R. So if this radius is R, so this is R, that makes this side twice R, this rectangle twice R. And we don't know what this portion is. So let me call this as X and this also X. And the circumference, we know circumference is 2 pi r. This is half the circumference, so this would be 2 pi r divided by 2. So the perimeter would be, you add up everything, the boundary, that is the perimeter. So let's do this sum. So question number A1. So the perimeter of the entire structure is 25 centimeters, that is given. This type of sum is more like the maximum minimum sum, where you have to show an expression of the area or volume. That is the question here. So the perimeter of this region, so we have this total perimeter is 25. So we have this, the arc, which is semicircular arc. This is 2 pi r divided by 2, plus we have this side x, plus we have this side x, and plus we have this is twice r. Together the perimeter is 25. So now if we simplify, so pi and pi cancels, 2 and 2 cancel, this would be pi r plus twice x plus 2r equals to 25. So now we can write twice x equals to 25 minus 2r minus pi r. Remember, we are finding an expression for x here. PQ is x. So therefore we can write x equals to 25 minus 2r minus pi r divided by 2. So we know that we have to use pi as 22 by 7. Remember, pi is not 22 by 7. It is in this sum they're telling us to use 22 by 7. Otherwise you cannot use pi to be 22 by 7. So anyway, this is half, and we can write 25 minus 2 r minus pi is 22 by 7 r, and if we use the calculator for the LCMs, it would be therefore PQ equals to half 25 minus, so minus 2 minus 22 by 7, that should be minus 2 minus 22 by 7, that should be minus 36 by 7, and that's shown. So minus 36 by 7r. That is the expression for this PQ. Now we have to find the area of this region. So in number 2 here, the area of this region is going to be area of the semicircle, which is pi r squared divided by 2, plus area of this rectangle, which is length into breadth. Now if the length is x, and the breadth is 2r, so area of a rectangle is length into breadth, then what we can do here, we can replace this x with what we found before. We can write, instead of pi, we can write 22 by 7, so this is r squared by 2, so plus 2r, and instead of x, we can write this, half 25 minus 36, let me write it again, so 36r by 7. So now we have to do a little bit of simplifying. So for doing that, we can cancel this 2 with this 22. So this would be 11 by 7 r squared, plus this would, we can cancel this 2 and this. So it would be 25r minus this would be 36 by 7 r squared. Now if we cancel this off, so we can get, so 11 by 7 r square minus 36 by 7 r square. So this would be 25r minus, so if we use the calculator, since both are r square, we can take r square common and we can write 11 by 7 minus 36 by 7, and that would be minus 25 by 7. So this would be minus 25 by 7 r squared. Now if we take here 25r common, So 25r as common, we will get 1 minus r by 7 shown. That's the expression. Okay, let's move on to the next one. So in the next question, what we have to do is we have to fill up the table. Usually it is a Cartesian equation where we have x and y, and instead here they're giving us an expression for area. So instead of the x-axis we have r, the radius, and instead of the y-axis we have a, the area, and the values of r is given. All we have to do is put the values of y coordinate or a here. You have to remember nowadays they're going to tell you just to fill up the x and the y. That's it. And you don't have to worry about even the graph. They would print the axis, but previously you have to put it yourself. So anyway, let's use the calculator for this. So a good way of doing this is to write down the equation. So if I convert this equation into x and y, then a would be y, and it would look like 25x 1 minus x by 7. This is what it would look like. So when you write this in the calculator, you can write it like this: 25, use the alpha here, x, and then use the bracket, 1 minus, this would be 1 minus x by 7. So again, this is x by 7. So now we press the calc button so that this is written here. Now we can just put the value. So 1, when I put x equals to 1, when we have this question mark, if I put 1 here, equals to, this would be 21.4. So let's fill this up, 21.4. So this is 21.4. The next thing, again press the calc button. Next is 1.5. So this is 1.5. That would give us 29.5. 29.5. Next we have 3.5. So let's press this calc button again. We have 3.5. This is 43.75 or 43.8. So this would be 43.8. Remember, we have to write this down in 1 decimal places. So it has to be 43.8. Finally, when we have this 4, we have to put down 42.9. So this is 42.9. So these are the values that we have. Next, if you want to fill this up too, so it would be 25 into r. So 25 into 1 is 25, 25 into 1.5, 25 into 3.5, 25 into 4 is 100, and then 1 minus 1 by this is 1 minus 1 by 7, and you can fill this up using the calculator too, but this is the main thing, the x coordinate and the y coordinate. These two are the main thing. Okay, question number C on the graph paper. So this is, they're telling us 2 centimeter. Remember, every square is 1 centimeter. So 2 centimeter means you have to use 2 square for 1 unit on the x-axis. X-axis is r-axis here. We need 0 to 5. And for the y-axis, every centimeter means every square represents 5 unit. This would be printed nowadays. You don't have to worry about that. So this is what it would look like. So for every 2 centimeter, we have 1 unit here on the x-axis or r-axis. Remember to label it r-axis. And on the y, which is the a-axis, we have every centimeter or every square to be 5 units. So this is it. So now we have to plot this. So let's plot this. So the first value that we have is this. When we have x equals to 0, y equals to, this is a, I can also call it y coordinate. So when we have x equals to 0, y equals to 0. So let's put the first value. So this is the first point. Let me use a different color here. Okay. So this is the first point. The next point that we have is when x coordinate is 1, y coordinate is 21.4. So we have, when we have 1, we have 21.4. So this is 1, 2, 3, 4, 5. So around here. So since this is every small box, every small square is 1, so we can use this. So the next one is when the unit is 1.5, the y coordinate is 29.5. So this is 1.5 and this is 29.5 is somewhere around here. Then we have when the unit is 2, we have 35.7. So when the unit is 2, we have 35.7, so less than 36, so somewhere around here. Next, when we have 3, we have 42.9. So when we have 3, we have 40, 41, 42, almost 43. So we have 42.9. Next, when we have 3.5, we have 43.8. So 3.5, we have 42, 43.8, 40, 41, 42, 43, like this, somewhere around here. Okay, that is 3.5. We're almost done. When we have 4, it is 42.9. So when we have 4, we have 40, 41, 42. So 42.9 is going to be 40, 41, 42, somewhere around here. 40, 41, 42, 43, around here. Okay, now that is 42.9. Next we have 4.8. When we have 4.8, we have 37.7. So 4.8 is going to be here, and 37.7 is going to be 35, 36, 37, 37.7 is going to be around here. So this is the plotting. Now the next thing that we have to do, we have to join this. On the graph, we have to do this: plot all the points from your table and join them to form a smooth curve. So we have to join this. So let's join this. So from here to here, then we have from here to here, then from this point to this, this to this. So that's part of the curve that they gave us. So let's write question number C. So question number C, done in graph. Question number D. Now we have to use the graph. So use the graph to estimate the range of values of R for which the area is greater than 40 centimeters square. Now remember, the y coordinate is the area. So greater than 40, that means it has to be a line here. You have to draw a line here. And label it. So this is area is 40. It's like y equals to 40. Now if it has to be greater than this line, then it is intersecting at this point, and it is also intersecting at this point. So that means if you take the two values from here, this point is 2.5, and if you take this value over here, so this value is close to 4.5. We can write 4.4 or 4.45, it's all right. So in order for this curve to be greater than 40, so it has to be between these two. So this is the basic concept of inequality. So if you have this and you have a line this, and they're intersecting at the point A and B, so if you want this line to be, this region, so between the curve and this line, then it has to be between A to B. So this is what's happening. It has to be, the value of R has to be between 2.5 to 4.4 or 4.5. So that is going to be the answer. So question number D would have this answer: 2.5 to 4.4. That's it. That's write down the answer. Next, question number E. Find the value of R to 1 decimal places if the area of the, if a side of, if a square of side 2 r centimeter. So if this is a square, they did not say from your graph. So this is a different question. This is an irregular question. We don't have to use the graph. So that means if it's a square, so let's take a look at the picture. Okay, so they're talking about this PQST. So if PQST is what they're talking about, PQST. So this is P, this is Q, this is S, this is T. We already know this is twice R. They're saying what would be the value of R be if PQ, this is also 2R, if it's a square. We know that PQ is represented by this. So this is algebra. So this is an irregular question. And they're saying if this length, since this is already 2R, they're saying if this is a square, then what would be the value of R? So we know an expression for PQ. So if this thing is also twice R, then what would be the value of R? So let's do this sum using algebra. So that would be question number E. So if PQ is also equals to twice R, and we know PQ is half, 25 minus 36R by 7 equals to twice R. So let's solve this equation. So we can cross multiply, we can send this 2 to the other side. So it would be 25 minus 36R divided by 7 equals to 4R. Let's bring all the R on one side. So it would be 25 equals to 4R plus 36R by 7. And using the calculator, we can write 25 equals to, if I take R common, it would be 4 plus 36 by 7. So that would be 64 by 7. So 64 by 7 R. Therefore, R equals to, so 25 divided by 64 by 7. So that would be 25 divided by 64 by 7, and that is 2.73. So they told us to write down the answer in one decimal places, so it would be 2.7 centimeter. It might seem tricky because we are expecting to use the graph, and they said just find it. So this is simple algebra, it's not using the graph, so it might seem different. So question number F, hence from your graph. Now we have to find the graph. So we have to find the area. So we know the value of R, 2.7. So using that, we have to find the area. So this one is using the graph because they mention hence using the graph. So if 2.7, so 2.5, 2.6, 2.7, if 2.7 is the value of R, then what would be the area? So mark on the graph. Always doing these sums, it's a good idea to mark on the graph. So this is the value we are looking for, and this value is close to 41. Looks like 41 to me around here. So this is 41. That's what it looks like. So let's write down the answer. So question number F is going to be 41 centimeters squared. That's it. If you show it in the graph, you don't have to mention anything, just write down the answer.